Hello everyone, welcome back to my channel Tech World with Preet. In this series, we will be introducing some introduction about microservices. The topic covered in this series are introduction to microservices, what are the benefits of microservices, and what challenges we are facing as part of microservices. Let's start with what are microservices. Microservices is an architectural style in software development where a complex application is built as a collection of small independent services that can be developed, deployed, and scaled independently. Each service focuses on a specific business capability and communicate others through well-defined APIs. In case of monolithic architecture, the entire application is single and tightly bounded, while in case of microservices, all the services are working independently. We will now compare the microservices with monolithic architecture. In monolithic architecture, the entire application is typically a single code base and all its components are tightly connected. This can lead to the challenges when it comes to the maintenance, scalability, and development. In contrast, microservices break the application into smaller self-contained services that can be developed and deployed independently. This decoupling of components allows for greater flexibility and agility in development and operations. There are key differences between the microservices and monolithic architecture. From the size and scope perspective, microservices are smaller, focused on specific function, while monolithics are large and encompass the entire application. Deployment. Microservices can be independently developed, whereas monolithics are typically developed as whole. Technological heterogeneity. Microservices can use different technologies and programming languages while monolithics are uniform. And scaling. So microservices can be scaled individually based on the demands while monolithics are using as a single unit. There are several benefits once you go for choosing the microservices. The first one is scalability. Microservices allow you to scale your individual services independently, which means you can allocate resources when they are needed most. This results in better resource utilization and improve the performance. The next one is agility. The modular nature of microservices facilitate rapid development and deployment. Teams can work on different services concurrently, leading to faster time to the market. Third one is technology heterogeneity. Microservices let you choose the best technology stack for each service. This means you can leverage the right tool for the job rather than being limited to a single technology stack. Independent development. Teams can work on different microservices without interfering with each other. This will help you to reduce the development bottlenecks and the conflicts. Fault isolation. If one microservice fails, it does not necessarily bring down the entire system. This isolation ensures that the failure of one service does not have a domino effects on other. Let's elaborate further about the scalability benefits. So, microservices architecture offers significant benefits in terms of scalability. For example, granular scalability. With microservices, you can scale individual services independently, which means you can allocate resources based on the specific need for each service. In contrast, if you see the monolithic architecture, you typically have to scale the entire application, even if only a few components require the additional resources. Point number two, from the cost efficient perspective. Granular scalability optimizes the resource utilization. You are not over provisioning resources for all the parts of the application, which will help you to reduce the infrastructure cost. This is especially beneficial for cloud-based application where you pay for the resources what you are consuming. And the third one is the performance optimization. Scaling only the services under heavy load resources, optimal performance and responsiveness for your application, even during traffic spikes or variation in usage patterns. Now let's see agility in more detail. The first one is the faster development. Development team can work on individual services simultaneously. This parallel development approach accelerates the overall development process. Different teams or developers can work on different services without waiting for dependencies to be resolved. Point number two is rapid deployment. Similarly, smaller independently deployable services allow for faster releases. You can introduce new features or updates to the specific services without affecting the entire application. This results in the short release cycle and quicker time to the market. The final one is continuous integration and continuous deployment, which we call as CI/CD pipeline. Microservices are well suited for implementing CI/CD pipelines, automating testing, and ensuring consistent, reliable deployments. This contributes to a more agile development and release process. Technology heterogeneity. Microservices architecture embraces technology diversities, which means we need to choose the right tool for the job. Each service can be developed using the most appropriate technology stack for its specific requirements. For example, one service might be using the Node.js while another uses the Python. This flexibility allows you to choose the right tools for each task, optimizing the performance and the efficiency for your application. Vendor agnosticism. You are not locked into a single vendor's technology stack. This makes it easier to adopt to emerging technologies and integrate third-party services, which can be crucial for staying competitive. The next benefit is independent development. Independence is a key benefit of microservices. For example, team autonomy. Development teams can work independently on their assigned microservices. They have the freedom to choose their development tools, processes, methodologies, which can lead to improve the creativity and the ownership. Point number two is reduce the conflicts. Independent development reduces the conflicts and bottlenecks that often arise in monolithic development, where team might need to coordinate their work more tightly. And the last is easier maintenance. Smaller self-contained services are easier to maintain. When update or bugs fixes are required, you only need to focus on the affected services, which makes the maintenance more manageable. And finally, we will cover the fault isolation benefits. Resilience. If a single microservice fails, it does not necessarily impact the entire application. Other services can continue to operate, offering a level of fault tolerance and reducing system-wide disruption. Point number two is easier troubleshooting. Isolating problems to a specific service simplifies the troubleshooting and debugging. Teams can pinpoint issues quickly and address them without affecting other parts of the application. Improve availability. Fault isolation contributes to higher availability since failures are localized and don't bring down the entire application. Now let's discuss some of the challenges with microservices. Along with benefits, definitely there can be some challenges in the microservices. The first one is distributed system complexity. Then we can see the service communication, monitoring and debugging, data management, and testing challenges. Now let's understand everything. Distributed system complexity, network latency. Communication between microservices often occurs over a network, which introduces latency. This can impact the overall performance of the application, especially if the services need to communicate frequently. Service discovery. Microservices need to discover and connect to each other. Implementing service discovery mechanism like Eureka or Console adds complexity to the system. Data consistency. Maintaining data consistency across microservices can be challenging. Distributed transactions are more complex to implement and can lead to issues like data anomalies or the conflicts. Distributed failure handling. With multiple services, you must handle failures gracefully. This includes scenarios like network failures, service unavailability, and the timeouts. For service communication, now let's try to see what are the challenges we can see while developing the microservices. The first one is the API design. Defining and evolving APIs that are stable, efficient, and well documented is critical. Inconsistent or poorly designed APIs can lead to integration difficulties. Data transfer. Deciding on data transfer formats like it is a JSON or a protocol buffers, and the serialization and deserialization method is very important while doing the data exchange. Then third one is the protocol and message format. Choosing the right communication protocol, for example REST, gRPC, AMQP, and message format for service to service communication is very important. And the final one is synchronous versus asynchronous communication. Deciding when to use synchronous or asynchronous communication method based on the requirement of each service. Now let's see some of the challenges which are happening with data management. The first one is database per service. Each microservice may have its own database. Maintaining data consistency, schema changes, and data migration become very complex. Point number 2 is data ownership. Defining ownership and access control for data can be challenging when multiple services need to interact using the same data. And the final one is data synchronization. Ensuring data consistencies between services and handling scenarios like eventual consistency require careful design and synchronization mechanisms. Now let's see some of the challenges with monitoring and debugging. The first one is service tracing. Tracking the flow of requests across multiple microservices can be difficult without proper tracing mechanisms. Log aggregations. Aggregating and analyzing logs from various microservices can be complex, as each service may use different logging formats and the tools. Distributed debugging. Identifying and diagnosing issues that span multiple services, such as performance bottlenecks or service failures, can be challenging. And the health checks. Implementing and monitoring the health of multiple services to ensure they are responsive and operating correctly. Testing challenges. Let's see what all challenges we will be facing while testing the microservices. The first one is end-to-end testing. Testing an entire application that consists of numerous microservices can be complex and time consuming. Integration testing. Ensuring that microservices work correctly together even as they evolve independently can be challenging. Service mocking. Creating mock services to simulate the behavior of other microservices during testing can be labor intensive. Test data management. Managing test data for multiple databases and ensuring test environments are in sync can be complex.